Alright, so I'm going to be showing the solution for chapter 2, problem number 60. The problem goes, a subway train starts from rest at a station and accelerates at a rate of 1.60 meters per second squared for 14 seconds. It runs at constant speed for 70 seconds and slows down at a rate of 3.5 meters per second until it stops at the next station. Find the total distance covered. So we can find the total distance by kind of splitting up the problem into 3 parts. So the first part is we're going to find the distance of the train travels when it's at first accelerating. You can do that by using this equation right here. Our position equation. Alright, so let's solve it for the first distance that it travels. So for the first distance it travels, it starts from rest, so that means that is 0 right there. Our starting velocity is 0, and it starts from the beginning of the track, so that means our starting position is 0. So then for the first distance, for D1, we are only going to be looking at this right here. And we know that for the first distance, it accelerates at 1.6, so we just plug these values in. 1.60. And it accelerates at this for 14 seconds. 14.0 squared. Get that out of the way. And this will give us our first distance. And now we need to find the distance after it covers, like for the second part. And for the second part, you can just use this equation again. So for the second part of the problem, it runs at a constant speed for 70 seconds. And so then for that, we just plug in these values, so we'll call this distance right here D2. And D2 is this going to be the total distance so far. So this is going to be the distance from the second part, when it's running at constant speed, plus this part right here. Alright, so we just plug in the values that are given here. So it runs at a constant speed for 70 seconds. So since it runs at a constant speed, that means this acceleration is going to be 0. So we look at our starting velocity. And our starting velocity is the final value, is the velocity once it reaches this point. We can find that with the velocity equation. Which is final velocity equals the initial velocity plus acceleration times time. And we can find that by just plugging in the values again. So the initial velocity was 0 for the first part, so then it's just acceleration times time. So then the final velocity for that is equal to, let's see, where is that? 1.6 times 14 is our final velocity there. And this the final velocity of the first segment would be our initial velocity for the first part. So again, coming back here, so acceleration is 0, so get rid of that. Initial velocity was, let's see, it was 1.60 times 14.0. All right, so that is our initial velocity to plug in right here. And then our initial x position, which is just right here, just d1, so then it's just plus d1. Alright, so now we have the distance covered for like the first two parts. For the first two parts together, now we define d3, and d3 will be our total distance. So we need to find we need to add on the distance of the final part when the train is slowing down. And after it runs at a constant speed for 70 seconds, it slows down at a rate of 3.5 meters per second squared until it stops at the next station. Alright, so for here, we know what our acceleration is. And that is a negative 3.5 because it's slowing down. We do not know t yet for this segment because we don't know how long it took for it to come to a stop. And then we know what, and then the initial velocity is just this right here in the previous problem. And that t, and our initial position, which was d2. Alright, so if we were able to, so once we solve this equation, we'll have the total distance traveled. In order to do that, we need to find t. And we can easily find t because it said the final velocity is equal to 0. So we can then use this equation. So if the final velocity is equal to 0, and the initial velocity is equal to 1.6 times 14, plus acceleration, so it's minus because acceleration here is 3.5, negative 3.5. And then using this equation, we can easily solve for t. Yeah, so you can just solve for t for this equation. And after you solve for t for that equation right here, just plug in t to this value right here. And then the result of this equation should be the total distance traveled by the train. And if you plug all those numbers in and account for significant figures, the total distance, or d3, will come out to be 1,796 meters.